The video today explores the balancing of chemical equations. This is our fourth activity in the unit on Cool Chemistry Show. And so there are a few things I'd like you to be able to do today. One is that you should be able to identify reactants and products. Two, you should be able to identify reaction types. And the last one is you should be able to balance a chemical equation. So to begin with, a general chemical equation, it doesn't matter what type of reaction we're looking at, but the reactants are always going to be listed on the left side of the arrow, and the products are always going to be listed on the right side. And you'll always see it in this format in this class. So you should be able to look at a problem and tell me what the reactants are and what the products are. Now there are four types of reactions that we're going to look at in this unit here. The first is a synthesis reaction where you take two reactants and those form one product. And so our general formula would be A plus B forms AB, and then an example would be sodium plus chlorine forms sodium chloride. Now, on the left side of the screen here is my reactants, and on the right side is my product, and it'll always be listed that way. And you'll notice that I've got two things on the reactant side, one thing on the product side. That's a synthesis reaction. Decomposition reactions, on the other hand, are one reactant, and they're going to break down into two or more products. And so the general formula of this is going to be AB forms A plus B. And as an example, we've got H2O breaks down into hydrogen gas and oxygen gas. Again, my reactants are on the left side of the arrow, and my products are on the right side of the arrow. You'll see I have one reactant and two products in this case, compared to synthesis reactions, which were two reactants and one product. Single replacement reactions are going to be formed between an element, a single element, and a compound, or the reactants. And then the products are going to be a new element by itself and a new compound formed. And so our general formula is A plus BC forms AC plus B. And basically what happens is the metal that's in the compound switches places with the element that's by itself. An example of this would be lithium plus sodium hydroxide forms lithium hydroxide and sodium. And if you look at this problem here, what we have happening here is that the Na and the Li are switching places. Now, in this case here, sodium's a +1 and lithium's a +1 when it's in that compound, but it may look slightly different if there are a difference in charges. And we'll look at that here in a little bit. Our fourth reaction type is what's called a double replacement reaction. In this case, two compounds are the reactants, and we have two compounds are the products. And so the general formula of this is AB plus CD forms AD plus CB. And our example problem here is that we've got lithium chloride plus magnesium oxide forms lithium oxide and magnesium chloride. And so when you look at this, the magnesium and the lithium are switching places in this problem here. Okay? And same thing with the lithium and the magnesium over on this part here. And so magnesium's a +2 and oxygen's a -2, so that's why it's just MgO. But then on the product side, lithium's only +1, and oxygen's still -2, so you need two lithiums for every oxygen. So let's go ahead and work through balancing a reaction here. And a couple things to remember is that the reactants must be present on the product side. So whatever you add to the reactant side has to end up on the product side. The other thing to remember is that we can only have the products on the product side when everything's done and it's balanced. So if we look at lithium plus aluminum hydroxide forms lithium hydroxide and aluminum, the first thing I'm going to notice is that this is a single element, lithium, plus a compound, aluminum hydroxide, forming a new compound, lithium hydroxide, and a new element, aluminum. So this is a single replacement reaction. I'm going to go through and I'm going to balance this by making a T-chart first, separating my reactants from my products. And whatever is on my reactant side has to show up on the product side. So to begin with, I know I'm going to have a lithium, and so that's got to go on both sides. And then I've got an aluminum that goes on both sides. And then notice how the OH shows on both sides as is, so I can just write OH 3 times because it's in that parentheses. And that OH can go on the product side. Okay. Now, on the product side, the only thing I can have is lithium hydroxide and aluminum. And so I've already started by forming one lithium hydroxide, but then I've got these extra OHs here. And that's not one of my products. Okay? And I've got aluminum, which is on the product side, and that's fine as is. But I have to take care of these hydroxides that are by themselves. And the only thing I can form them as is lithium hydroxide. So I'm going to go back to the reactant side, and I'm going to add additional lithiums. And when I do that, the lithiums show up on the product side. But if you look back at my original problem, it only currently says 1 lithium plus aluminum hydroxide forms lithium hydroxide and 1 aluminum. But that's not the case that we see down below. So we have to update this with coefficients. So how many lithiums did I need altogether? I needed 3 of them. How many aluminum hydroxides did I need? I needed 1 of them. How many lithium hydroxides did I form? I formed 3 of them, and I formed 1 aluminum. If I needed more aluminum, the only way I could add it would have been to add a complete aluminum hydroxide, okay, because it's not separated by a plus. But I can add lithium by itself because it's separated by that plus sign. I hope this helps you review balancing equations. I know it's been a little while since we've done this before break. Good luck with the packet, and I will see you on Monday.